And so it looks like we get half the graph by the time we get to pi. And let's take a look at our testing for rules over the y-axis. If we can change both of the theta and the r, and you get the same equation. So let's go back here, and if I change my r to negative r, and I change my theta to negative theta, I end up with negative r equals 8 sine of negative 2 theta. And if you recall your cofunction identity, that's the same as negative 8 sine of 2 theta. The negative comes out front. And then multiply by negative 1, and I'm left with r equals 8 sine of 2 theta. So we end up with the same thing as we had originally in there. So I know that over here, I'm going to have the same thing that I had on the other side. So using those, I can find half as many points and get the same picture. All right, so now let's talk 10.1. In 10.1, we're solving systems of equations, or 10.1. I think we already did 10.1, didn't we? Pause. All right, so I guess let's take a look at this 10.1. Is 14 negative 2 a solution to the system? So if I put in 14 plus negative 2, that equals 12. Yes, that's true. That is a solution to that equation. And if I put in 14 minus negative 2 does not equal 4, so we know that it would have to be true of both of them for it to be a solution to the system. Can't be just true of one. So we need both to be true. Okay. So the types of solutions that we get one value for each variable, and geometrically this is the point of intersection of two lines. We get no values for either variable, no solution. And in that case, we would say they are just parallel. And we get one value can be expressed as a multiple of the other. In that case, we know that they are the same line. The lines are over the top of each other, and all of the points are in common. And methods for finding the solution, I'm sure this is review. We do the substitution, and we do the elimination. Those are the methods that we can use. And so let's take a look at this one first. I'm going to do this first one by substitution. And to do substitution, we need to solve for one of the variables. So I'm going to solve for the y. And I get 4x minus 7. And then I substitute that into the other equation. So I get negative 2x plus 3 times the quantity 4x minus 7 equals 9. Simplifying that, I get negative 2x plus 12x minus 21 equals 9. And simplifying that down, I get a 10x equals 30, or x equals 3. And then you can substitute that back into either one of the original equations. So I'm going to go with 4 times 3 minus y equals 7. Negative y by minus the 12 gives me negative 5. So y must be positive 5. So the point of intersection of these two lines are at the point 3, 5. Now let's take a look at the second one. I'm going to try to use elimination by addition here. To do that, we need one of the values to be the same. So I'm going to multiply this top one by 3 and this bottom one by 2. I'm going to get a 12x on the top, and I'm going to get a negative 12x on the bottom. So I'm going to simplify that down to 12x plus 18y equals 9. On the bottom equation, I end up with negative 12x minus 18y equals negative 9. And when I add them together, I get 0, 0 equals 0. And we know that 0 equals 0 is a true statement. And so this is the case where they are the same line. So if they're the same line, we get infinitely many solutions. It's easy to confuse the no solution and infinitely many solutions. So check some points to make sure that they work. And let's try this one. Determine the equation of a parabola with a y-intercept of 1 that passes through those points. So we know that the general form of a parabola is y equals ax squared plus bx plus c. And we know 2 bits of information. We know that the y-intercept is 1, so that's our c. And we know the different points. So let's plug in this point first, and then we'll plug in that point to find out what happens. So if I plug in the first point, I get 11 equals a negative 1 squared plus b times negative 1 plus 1, because 1 is the y-intercept. And so I get 10 equals a, because it's negative 1 squared, minus b. Excuse me. And so I get an equation in terms of a and b when I do that. Let's do the same thing with the 3. So I get a y value of 1 equals a 3 squared plus b times 3 plus 1 again, because the y-intercept is 1. And so I get 0 equals 9a plus 3b. And wow, look at that. I get 2 equations, 2 unknown in a section with two equations and 2 unknowns. So we can do one of 2 things. We can either eliminate or we can substitute. I'm going to substitute, I guess, because a is equal to b plus 10. So if I do that, I get 9 times b plus 10 plus 3b equals 0. And I get 0 equals 9, well, it's 12b, because 9 and 3 makes 12b plus 90, or b is equal to negative 7.5. If I plug that back in here, I get minus negative 7.5 gives me plus. Subtract it from 10, I get a is 2.5. So my equation, using the 2 equations, 2 unknowns, gives me 2.5x squared plus, minus 7.5x plus 1, because our y-intercept is 1. So using that tool, we can get that. So let's go down here to one salt solution is a 15% salt solution, and the other one is 20% salt solution. How many milliliters of each solution must be mixed to obtain 50 milliliters of 16% solution? So I'm going to have solution 1 and solution 2. And I'm going to say the first one is a 15% solution, and we want to know how much of that to give me 0.15x, and the other one is a 0.2 times y gives me 0.2y. And I know that my equation 0.15x plus 0.2y is going to be equal to my 0.16 times 50 milliliters. And I can use that equation to say, hey, I get this same thing. Instead of 50 milliliters, I know that it's 0.16 of x plus y. So we get a system of equations that we can solve here, And if I recall correctly, I end up with, well, let's do a little bit of substitution here. I get x plus y equals 50. And I also get that 0.15x plus 0.2y equals 0.8. Oh, better use a calculator. I'm going to pause. And after simplifying, I got the systems of equations, and then I used substitution over here, and I ended up with y is equal to 10, so then x would be equal to 40, and of course they're in milliliters. Don't want to forget our labels. And we know that y is the 20%, so 10 of 20% solution and 40 of the 15% solution. Make sure you do a good job of labeling on those story problems. Alright, so then, non-linear systems of equations. Same dealio here. Let's take a look at what this might look like graphically. We know that my graph of the original here, let me put this in y equals negative x over 2 or negative 1/2 x plus 0. So if I'm graphing this, I have a graph that looks kind of like that. Might be a little less steep, I don't know. And then the other equation, the x times y equals negative 2, that's the same as y equals negative 2 over x, and that's going to give you a hyperbola in the negative, so it's going to go that way and that way. And so what we're looking for here is the intersection there and there. So we're going to get 2 points out of this. One of the things that we could do is use substitution. So let's see if I put y, I don't know which one I want to solve for. Let me pause. So since both of them are solved for y, I'm going to set them equal to each other. So on the first equation, I get negative x over 2 is equal to negative 2 over x. And so when I do my cross products there, I get negative x squared equals negative 4, or x squared equals 4, square root, square root. So my two x values end up being plus 2 and minus 2. Because I know that we're going to get 2 points, I'm going to start my 2 points with those values. When I plug the positive 2 into the first equation, I get 2 plus 2y equals 0. If I move the 2 to the other side, I get 2y equals negative 2, or y equals negative 1. When I do the same with the negative 2 in for x, I move it to the other side and I get 2y equals 2, and I get those points. Okay? So on this example here, I'm going to see if I can find the solutions, and I'm going to start a new video because there's not going to be enough time to finish that one.